In this section we discuss diffusion. You can smell the fragrance of a perfume at some distance from an open bottle because perfume molecules leave the space above the liquid in the bottle, where they are relatively concentrated, and spread out into the air, where they are less concentrated. During their journey, they collide with other molecules, so their paths resemble the zigzag paths characteristic of Brownian motion. The process in which molecules move from a region of higher concentration to one of lower concentration is called diffusion. Diffusion also occurs in liquids and solids, such as the example of a drop of ink diffusing through water. However, compared to the rate of diffusion in gases, the rate is generally smaller in liquids and even smaller in solids. The host medium, such as the air or water in the previous examples, is referred to as the solvent, while the diffusing substance, like the perfume molecules or the ink, is known as the solute. Relatively speaking, diffusion is a slow process, even in a gas, due to the nature of Brownian motion. The diffusion process can be described in terms of the following arrangement. A hollow channel of length L and cross-sectional area A is filled with a fluid. The left end of the channel is connected to a container in which the solute concentration C2 is relatively high, while the right end is connected to a container in which the solute concentration C1 is lower. These concentrations are defined as the total mass of the solute molecules divided by the volume of the solution, for example, 0.01 kilograms per meter cubed. Because of the difference in concentration between the ends of the channel, delta C equals C2 minus C1, there is a net diffusion of the solute from the left end to the right end. This behavior has much in common with the conduction of heat along a bar. When the ends of the bar are maintained at different temperatures, T2 and T1, the heat Q conducted along the bar in a time T is given by K A delta T times T divided by L, where delta T equals T2 minus T1 and K is the thermal conductivity. Whereas conduction is the flow of heat from a region of higher temperature to a region of lower temperature, diffusion is the mass flow of solute from a region of higher concentration to a region of lower concentration. By analogy with the heat flow equation, it is possible to write an equation for diffusion. First, we replace Q by the mass m of solute that is diffusing through the channel. Next, replace K with the diffusion constant d. Finally, replace delta T by the difference in concentrations delta C equals C2 minus C1. The resulting equation, first formulated by the German physiologist Adolf Fick, is referred to as Fick's law of diffusion. It can be verified from the equation that the diffusion constant has units of meters squared per second, the exact value depending on the nature of the solute and the solvent. For example, the diffusion constant for ink in water is different from that for ink in benzene. In summary, the process in which molecules move from a region of higher concentration to lower concentration is called diffusion. The host medium is called the solvent, the diffusing substance is called the solute. Brownian motion is responsible for the slow process of diffusion. In Fick's law, the mass m of solute that diffuses in a time t through a solvent contained in a channel of length L and cross-sectional area A is given by m equals dA delta C times T divided by L. The SI unit for the diffusion constant d is meters squared per second.